Right, welcome back to ArmanisMath. Today we're going to focus on the unit circle. And let's take a look here. What we've got is a circle with a unit of 1. So the radius is 1. And the radius doesn't change throughout all the circle. This is 1, this is 1, this is 1, and this is 1. That's why it's called the unit circle. Not just that, but if you also have a radius here, it's going to be 1. That's going to be 1. Anywhere in the circle, they have a radius of 1. That's why it's called the unit circle. So keep that in mind as you are thinking about these problems here. Also, understand that we're talking about a circle that is that's got 4 different quadrants. This is quadrant 1. This is quadrant 2. This is a third quadrant. Third quadrant. This is the fourth quadrant. Quadrants. So I know 2 things right now. I know this is a circle. This is a radius of 1, and the radius does not change. It's 1 throughout the circle. I also know that the circle is divided into 4 quadrants, 4 quarters if you want to call them that. This main point here is the x-axis, right? X-axis is here. So you walked only 1 unit, right? Just 1 unit here. So that's why the point here, when you touch the circle, the point is going to be 1, 0. You did not go anywhere with up or down, so that's why this y is 0. Also remember that this is x and this is y. And again, if you guys remember, every x we called it what? Somebody help me? I need a lot of participation today, okay? Every x we call what? Finish this up for me. Cosine, thank you, Giovanni. And every y we called it what? What do we call every y? I need to see a lot of participation again. Cameras, chat, private chat, comment on the live stream, whatever you have to do to show what you know. Here we go. I see some. Yep, here we go. You're right. It is sine. Every x is cosine. Every y is sine. Now the way I do the unit circle is I'm going to do actually 3 graphs. Okay, 3 graphs. So I'm expecting you to do the 3 graphs, 3 circles. Make them really large and big like this, and then eventually we're going to take a look at the 4th one where we're going to fill more information on top of it. So that's the first one we're going to do. Walk with me, or I should say maybe rotate with me. Just maybe think that you're in Santa Cruz Boardwalk and you're on the merry-go-round and you're just rotating, okay? So we're going to rotate, and rotation in math, remember, you rotate counterclockwise against the clock. Now, some of you might not have an analog clock, but this is the way the clock would rotate in an analog clock, not the one that is digital. Okay, so I start from here, and then I go like this. So if I moved like that, I'm going to move 90 degrees angle. See this here? It's a right angle. This guy's right angle. This guy's right angle, meaning 90 degrees. These 2 lines are perpendicular, so you expect to see 90 degrees on 4 of them. So if this is 90 degrees, I'm going to get to 90 degrees. If this was a 0 starting point, 0 is the point, 0 degrees here, then I'm going all the way down here to 90 degrees, 90 degrees. If you add another 90 to the 90, you end up with what? What is 90 plus 90? Actually make that live so others would benefit from it as well. Let's go put that public so others can benefit as well. You might send this one to somebody else, like even outside of school. It's open to the public now. Okay. By the way, your names and chats would not show up in the live in the YouTube live. 90 is here, and you add another 90, you get to 180. So I've got 180 here degrees. Keep counting with me here. Keep rotating. Okay. Again, you're on the merry-go-round here, and you're rotating. You get, what is 180 plus 90? 180 plus 90. $270. 270. Yours, Lindsay, yours would be next. 270. Okay. 270 degrees. Don't forget that. And then again, another 90 to that. Another 90 to 270. Meaning you have 4 90s. You're going to land on top of the 3 of the 0, which is going to be 360. So the 0 and 360 kind of live in the same place. 0 and 360 co-inhabit the same place. All right. Talks about angles in degrees. Now, last time, if you guys remember, there was 2 measures of the angle. Just like, as we said, about the distance. Kilometers in Canada and Mexico, for example, and miles in the US. Or Fahrenheit for temperature in the US, while Celsius is used in a lot of other countries. Angle has 2 different measures referring to the same thing. 2 different measures. One of them is called the degrees, which is that little circle that you see. And the other one is called pi radians. Radians. You don't really say radian, you just use the word pi. So right now what we've done is started from 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back to 360 degrees, right? Now, what is the equivalent in terms of pi radians? We spent last time developing this very thoroughly, so check your notebook. You should see a circle with, you should see semicircles, I should say, half circles. Remember when you did the half of, we did this here, and we did another one here, and another one here. I remember we did that. So take a look at your notebook. You should see something like this: a half a circle and a half, because you go from 0, the top of the unit circle, or the top half of the circle at the top, we call this as a pi. So from 0 all the way to 180, it's a pi. So you take the pi and then you slice the pi. So I do remember slicing it with you guys when we did the halves. Does anybody remember that? Give me a yes in the chat, please. Look at your notebook, see if we have halves. Here we go, good. So exactly at this midpoint, I got a half of the pi. And then we took it also again, and then we said, you know what, I want to divide it into quarters. Excuse my graph here, a little bit. Let me go this way. And then we said this is quarters. So a quarter of the pi, and then a second quarter of the pi, third, and then fourth quarter of the pi. And then we also did, also thirds, because thirds, third, this would be like pi, 0, and then again pi. This would be 1/3 of the pi, pi over 3. 1/3 is the same as pi over 3. Also, this was a sixth one, I should say a fourth one, which we did it in 6 pieces. So if you don't have that, you might want to just include that as well. You just divide the pi into 6 pieces. Slice it into 6 pieces. So if I go like this, halfway is going to be like that. And then one more time, And if you divide the pie in 6 pieces, well, it's pi over 6, right? 6 pieces. 6 friends, 6 pieces. So each piece would be pi over 6, or 1/6 of the pie. This guy is going to be 1/6 of the pie, which is pi over 6. So let's talk about this a little bit here. If you said half of the pie, let's go at the top here, half of the pie. If I know the pie is 180, half of 180 is how much? Every pie is 180 degrees. Half of the 180 is how much? $90, exactly. So at 90, this pi over 2 is 90. This pi over 2 is exactly as 90, right? You could say or 90. How about pi over 4? You took the 180 and you divide that into 4 slices. You slice that into 4. How much would each slice be? How many degrees do you think? If this whole thing is 180 and I have it cut in 4 pieces, 4 equal pieces, how much is each piece? A little bit bigger than that. Because if I took this 180, let's say you took the 180 and then divided by 2. We just did that and we got 90, right? Remember that? We got 90. So what if you divide the 90 into 2 parts? How much would that be? That will be 45. You're right. It will be 45. So pi over 4 is 45 degrees. So you could say or 45 degrees. Okay, what about pi over 3? Well, again, I'm going to take the 180 degrees, divide that into 3. So try to do that and let me know how much. $180 into 3 equal parts. How much would that be? Need somebody else to help Giovanni, okay? How about the Kieras? How about the Andrea and Lindsay and all of us here? You guys could do that. Here we go. Kathleen, I see that. Myra, I see that. Lindsay. Even if you're not sure, you just have to give me some thoughts, okay? Remember, you share thoughts here. Could be correct answer, could not be correct answer. 60. If you divide 180 divide by 3, that's going to give you the 60. 60 degrees, basically. So each one of these little slices is a 60 degrees. Okay, next one. Pi over 6. So now you're taking the 60, instead of pi over 3, right, 60, you take the 60 and divide that into a half, into 2. How much would that be? Or you take the 180 divided by 6. That's also another way to get there. How much would that be? Somebody help Giovanni, you guys. You gotta shine just like Giovanni, okay? Or 30. That's very true. So I'm gonna put kind of a green color on the bottom here. So I know pi over 6 is 30, pi over 3 is 60, pi over 4 is 45, pi over 2 is gonna be 90. So all what I'm gonna do now is come up at my on my circle here and just label them. So now I know that there are some other names for the same angle, just another name for the angle. And the other name here is gonna be pi over 2. Pi over 2 here. And I've got a pi. And how many pies? If you're counting by halves, half a pi, 2 halves of the pi, which is going to give you a pi. How about add another half? How much would that be? Add another half to the pi, what would that give you? Are you counting with me? 1/2 of the pi is going to give you 90. 2 halves is going to give you 180. What would 370 be in terms of halves? How many halves is the 270? That's exactly correct. It is 3 halves. Because if you're counting by halves, that's going to be 3 halves. So this 70 is 3 halves. 3/2 of the pi. And you also might want to include this, because when you add another half, you're basically saying you have 4 halves. What? 4 halves? Yeah, 4 halves. 4 halves of the pi. Which means what? What is 4/2? How much is 4 divided by 2 equal to? 4 divided by 2 is just a 2. So the 360 has another name, which is 2 pi. Okay? So all what we've done right now is just label the angles. Right? We said this is a unit circle, a radius of 1. We said this is divided into 4 quadrants, 1, 2, 3, 4. And we also said that the angles could be either in degrees, the black one, or in radians, which is the green ones here. So now follow along with me. Let's do some points on this circle. So I've got this 0 at 0 degrees. I have 1 comma 0. The 1 is the cosine and the 0 is the sine. Now let's move on to the 90. Okay, let's look at the 90 here. If this is a 1 unit here, how much do you think is the point? What would the point be at the top here? In terms of x and y, what would that point be? If this radius is 1, what would the point at the top be? Give me some thoughts, you guys. Okay. Okay, remember the maximum is 1. That's the radius. So I cannot see that. So hold on. Let me take you back to this point here. Let's take a look at this point here. You see this point here on the right side? I walked 1, right? On the x-axis 1 because the radius is 1, and I did not go up or down. So that's the reason it was a 1 comma 0. Here, I'm gonna walk on the y-axis 1, but I did not do anything to the x-axis. So the point is gonna be what? What's my x here? The x is 0. 0, 0, and the y is gonna be what? How much is the y again? It's 1. That's the maximum. Remember, on the unit circle, the maximum is that 1. Okay, follow along with me now. Keep rotating. Don't get dizzy. Just keep rotating here. Remember, we're doing counterclockwise this direction here. So why don't you think about this with me here? I am here at 180 exactly, at this point here. What could be the coordinate points? What are the x's and y's here at this point? X, comma, y. Opposite of 1, yes, Kennedy, which is what? If you have, this is the positive x, this is the negative x. Yep, it is negative 1. Negative 1, comma 0. See that? Negative 1, comma 0. And how about the one down here? I have to come up with x and y here. What do you think is going to be the one down here? What's the coordinate here? All right, for the x, I did not move anywhere with the x. Did not go right or left, right? It's 0. For the y, I see that there. I see that Tatiana. I see that Kathleen. And I see that Giovanni and Kennedy. Okay. I see -1. -1 is correct. Olivia, I see that. -1 is correct. So basically I have 0 and -1. Don't forget that each one of these is x and y. X and y, x and y. And every x is what? Does anybody remember? Every x equals to what? That's exactly, yes. Every x is cosine, every y is sine. Don't forget that, okay? So for example, right now I have, like, I'm basically giving you a test question. Did you hear that? Did you hear what I said? Did you just hear that? Okay, anyways. So let's say, for example, I'm going to say, give me sine 90. Well, what are you going to do? I'm going to go to 90, which means I'm at the top here. Every x is cosine. Every y is sine. So if he wants sine 90, which one do you think he's going to pick? Yes. Simple as that. Sine 90 equals to 1. I'm going to pick this one. Let's try one more time. What if I want cosine 180? How much is cosine 180? Somebody has to talk to Kathleen. Somebody has to compete here. Come on, you guys. Shine light. Cosine 180. Cosine 180. Very interesting. How do I get that? How do I get cosine 180? How about the rest of us, you guys? Olsen, Myra, Nick, Olivia, Ryan, Shalom, Shalom, Yurshi, Shine, you guys. Kennedy, Juliana's. It's over here. You don't even have to touch any calculator, by the way. And no calculator needed here whatsoever. If I said cosine 180, you would go to the 180 point here. This point here. And you focus on the x or the y. Is cosine x or y? Is cosine x or y? Cosine is x, Armani. So basically you're going to look here at this side here. This is cosine. Remember cosine here. So you're going to say this is actually going to be a -1. -1. Okay, now it's your time to quiz me. Put something in the chat, quiz me. Which one? You are going to give me a quiz right now. Give me a quiz question. You've got this whole unit circle here. Quiz me. That's too many of you. One at a time, please. Come on, you guys. I am waiting. Brianna, give me a quiz question. Elijah, give me a quiz question. You guys are going to quiz me on this here. Give me one question. Each one of you give me one question. Joseph and Juliana's both of them. And Kennedy, find sine 270. Okay, Kathleen, 270. I'm going to go all the way to this point here. And I'm going to focus on the y side because the y is the sine. Okay, so sine. I'm going to write it down. Sine 270 will equal to -1. I didn't even touch it. There's no need to touch a calculator. Why would there's no need for that? I see another question here from Ford. Cosine 360. And okay, Ford, that's a tough one for me, but I'm gonna do it. Cosine 360 is the same as cosine 0, believe it or not. 0 degrees. So she's talking about this point here. And cosine is the x part, so I'm gonna pick 1. And that's it. That's gonna be the answer for that one. Who else got a question for me? Ford saying cosine 240. We have to wait for that one. We'll get to that, okay? That's why we did the pies here. We sliced the pie in different sections. Sneaky. You wanted to get me, but you gotta wait. Okay, Kathleen. Kennedy. Kennedy says find cosine 180. I thought we have that already. Cosine 180 is -1. You guys helped me out with that one. Okay. Anybody else? Anybody else who did not ask me before? It's okay. There's a lot you could ask here. All right. So that was the number 1 graph for the unit circle. So please erase what you've got because we're going to add some stuff to it. I shouldn't say erase. Maybe start a new graph. Start a new circle because we're going to add some stuff to it as well. Okay. So I'm going to pretend this is a new graph for me. And I am going to, actually I'm going to start a new graph. So let me start a new graph. Here is my circle. And there's my lines here. There's another one here. Kiera wanted to trick me and she said 240. But I said hold off a little bit. So let's do some kind of wacko ones here. We're gonna do, I'm gonna do the 60, meaning I'm gonna take this pie and slice it into 3 different sections, 3 different pieces. 1/3 of the pie here, this is 1/3, 1/3, and 2/3 of the pie, 2/3, and 3/3 of the pie, 3/3. 1/3, 2/3, 3/3. Remember, this is a pie here, so I'll take the top and divide that into 3 sections. So I'll say this is 60, another 60, and 60. All right. You already told me, by the way, that if this is 180, you divide 180 into 3, so each one becomes a pi over 3, which is equal to 60 degrees. 60 degrees. Actually, I could, and I might as well do it now. I'm just going to extend this to it down here. And also going to extend this to it down here. So I did not just divide the top into thirds, but also divided the bottom pi into thirds. So if I'm counting by thirds now, count with me. 1/3 of the pi, or you could say pi over 3, is the same thing. And then this guy here, including this piece here, is 2/3 of the pi. 2/3 of the pi, or 2 pi over 3. 3/3 of the pi. That's interesting. 3/3, that's like just a pi, isn't it? That is 1 pi. Well, that's very accurate, because on this guy, at this point, you're gonna actually add on pi. 3/3 is just 1. Help me out. What do I have here? If I'm counting by thirds, what would this be here? 1/3, 2/3, 3/3. What would this be? 4/3. It's very true. 4/3 of the pi. 4/3 of the pi. How much do you think would this be here? If I added another third. 5/3 of the pi. And the last one is going to be 6 what? 6/3 of the pi? Well, it looks a little bit familiar because 6 divided by 3 is how much? It's 2. 6 divided by 3 is 2. And that's why at this point, when you land here, you will land on 2 pi. Remember that? 2 pi and the 0, they live together in the same place. 0 degrees. 2 pi radians live in the same spot. Also with another friend, which is 360. Also with a lot of other friends, if you keep rotating, you're gonna keep adding 360, another 360. So that's how we count with 1/3. Now let's take a look at the 60. You said 1/3 is equal to 60. Now talk about degrees, okay? So if this is 1/3, that's gonna be a 60 here. You guys agree? 60 degrees. Let me put it here. I'm going to put 60 here. 60 degrees. Which was pi over 3. That's exactly what the 60 is. Okay, keep counting with me here. 60 degrees. And then add another 60 degrees. How much would that give you? 60 plus 60. $120. That's very true. So I have 120, which is 2/3 of the pi. 2/3 of the pi. All right, keep counting here. I add 60 to 120. How much would that? How much is 60 plus 120? And all of us should know this one now. Yeah, like this one here. What is this guy here? Yeah, that's 180. Armani, come on. That's 180. So remember, 180 is equivalent to the pi itself, right? That's 180. Now let's keep counting again. I got 180 plus another 60. How much is 180 plus 60? I'm just adding 60s. I'm adding 60s. I'm adding 60s. So I got 180. 180 plus another 60. I'm rotating this way. Aha, Tatiana. Yes. And that's Kiera Ford's tricky question. This is actually 240. 240 was how many thirds did you count for 240? How many thirds of the pi did you count? If you're counting by thirds of the pi, how many thirds did you exactly? You got up 4/3. 4/3 of the pi, or 4 pi over 3. 4 pi over 3. That's exactly 240. That's why I told 4 to 8 a little bit. So keep going here. I've got another 60. How much would that be? Another 60. How much would that be? Basically 300. That's precisely the number here. 300. Which is how many 6s of the pi? How many thirds did you add? How many 60s? How many thirds did you add to get there? 6 of them would be all the way up here. So that's what's coming up next, Tati. 6 would be coming up here. 5, exactly. 5 pi's. 5 pi over 6, which is that amount. Now I'm going to take Tati's 6 pi over 3. I got basically I got the pi, and I have 6 pi's over 3. 6 over 3 of the pi is basically just 2 pi's. And when you add 300 plus 60, how much would you get? 360 degrees, 360 degrees, which is same as 0. Guys, remember, it's the same as 0 degrees, right? And also don't forget that this is 2 pi. 2 pi. Same measure. All right, let's put some points. For this one, we have to know your 30-60 triangle. That's why we spend a lot of time on the 30-60 triangle and 45-45. It's because of this. So let me put the 30-60 triangle. That is not a triangle. I need a triangle, which is down here. And this triangle will be this triangle would be something like hold on a second. It will be something like this. That's very steep, yeah. So look into your triangles, special triangles, and this is now 60. 60 is down here this time. Why is 60 down here? Because 60 is going to face the longer side, remember? And this is the longer side. We're just basically flipping the triangle. The ratio did not change. This is just it being stand on its side. If it's a 60 down here. So remember, we developed this triangle in the past and we wanted the radius to be 1. Can somebody give me what is adjacent to the 60 and what is opposite of the 60? Look at your index card. I hope you had an index card for that by now. If not, look at your notes. We are looking at the 30-60 triangle. Somebody gave me the cosine, the number that is next to, right adjacent of the 60. What is the cosine? What's the number here? Adjacent, I would look again. Yeah, I would look again. Adjacent of 60 should be the little number, not the small one. No, I'm sorry, not the bigger one. You might need to flip. Just look at the triangle correctly. Look at whatever is next to the 60, and it should be the smaller side. This guy here. Yep, it's this one. It's just 1/2. If you wanted that, it's going to be just 1/2. So I'm going to put 1/2. The longer one is obviously more than 1/2, which is a square 3/2. Also, a quick comment here for you: the square of 3, belongs to the 30-60 triangle. Square root of 3. Look at the 3 here and the 30. This 3 here is matching this 3 and the 30. See that? So that's why you don't confuse the square root of 2 with the 30-60, because the square root of 3 belongs to the 30-60 triangle. Don't forget that. All right, so I'm gonna come here and believe it or not, all I have to do now is copy and paste this dude here. What do you mean? I'm just gonna paste the 60 triangle because this angle is 60. From here to there is 60, and I got 60 triangle. So that's exactly what I'm gonna do. I'm gonna copy and paste the triangle here. When I do that, I will go to my tool and change that into the 60. So basically I have a 60 triangle. This is my 60 triangle. I don't know, just clutter things, so I'm going to use a different shading here for that one and a lighter shading as well. All what I did is just copy and pasted my 30 and 60 here. In this case it's a 60. So this is 60 from here to here is 68, which matches exactly what you see here. Look, that's exactly what you see here. This triangle here matches exactly what you see. That's why I'm only copying and pasting it. That's all I do. So now, before I continue, I wanted you to help me with the ratios here. So let's together find this out. We did this before, but let's do it again. Cosine 60. How much is cosine 60? Look at 60 and give me the... What's the definition of cosine again? What's the definition of cosine? Something over something, right? What is that something? Cosine. Ding, cosine. Adjacent. Here we go. Cosine is adjacent. So adjacent over hypotenuse. All right. So think with me here. Adjacent of me, which means right next to me, and my elbow here. Which one is adjacent to me on the 60? Can somebody help me? Which one is adjacent to the 60? It's right next to the 60. The 1/2. Exactly. The 1/2. And you divide the 1/2 by 1, well, you get 1/2. So cosine 60 is going to be 1/2. Sine. How about sine 60? Some of you gave me the definition earlier. What is the definition of sine? Armani, sine is defined as opposite over hypotenuse. So ka towa, so ka towa, sa ka towa, so ka towa. So opposite of me, opposite of 60, you really have to know where you're at. Who are you? I am the 60. I am the 60. That's why your eyes have to be like this. You are looking from that perspective. I am the 60. Okay, if you're the 60, what's opposite of you? What's opposite of me if I'm the 60? Which side is opposite of me? That is very true. Kira and Kennedy, that is very true. That's square 3/2. That's what's opposite of me. Now we take that divided by 1. Well, that's just itself, right? Divide that by 1, that's going to give you the same value, which is square 3/2. Okay, are we good? I did the copying and pasting. All what I'm doing now is trying to find this point here. Remember, this guy was 1, 0, the x and y, the cosine and sine. I'm just trying to find it here. What is the x and y here? What is the cosine and sine here? That's what I'm trying to find. So based on what we just found here, what do you think is the cosine of 60? What do I put here for cosine of 60? Yes, it's there. You already have done the work for it. It is 1/2. Cosine of 60 is 1/2. How about the sine of 60? Remember, this is cosine. This is sine. How about the sine of 60? If cosine is 1/2, what would be the sine? What would the sine be? What would the sine be for cosine? For sine 60. Hello? Champions? I've got cosine of 1/2. What is sine 60? That's the one I need to fill out here. Sine 60 needs to go here. What is that amount? I've got... Again, if you see your friends put it, you also put it down, okay? Even if it's fine, you just put it down. Put your thoughts down. Slow down, you guys. Slow down a bit. Tatiana, here we go. Tatiana, I got you. You're correct. So square 3/2. How did you get that, Armani? Well, I got it from here. I got it from the triangle. That was not up from my sleeve. It was here. It was cosine of 60. We done it. Sine of 60 is that amount. I only take them and put them here. That's all I did. Cosine and sine. Remember, every cosine is x, every sine is y. And I put that right there, right in front of me. Okay. Now, before I continue with the 60 journey, I need you to be reminded of the following. What? I wanted us to remember the following. What's that following? That following is this. If I have x and y coordinates just like this here, or Cartesian coordinates, or rectangular coordinates, and I'm here, I'm in the first quadrant. Okay, think with me a little bit here. Pick any point here. Can somebody pick any point in the first quadrant? Hello? Can you pick any point in the first quadrant here? This one here. Pick any point here. A point, so x comma y. So I like that, but here we go. 1, 5, 1 comma 5. That's 1 point. Any point you'd like. And if you notice carefully here that the x is positive, you see that? And the y is positive. Do you all see that? X and y is positive. Which means the cosine is positive and the sine is positive. Yeah? Now somebody pick a point in the second quadrant here. By somebody, I mean all of us. So pick a point in the second quadrant. Any point you like. Any point? Yeah, any point. I see a negative, Keep going. Even if you put something down, you guys, if your friend puts it down, you also put it down. Pick any point. I'm actually going to wait for you, for all of us to do that. Go ahead and pick a point in the second quadrant here, somewhere here. Any point that you like. I need to see more than just what I'm looking at here. Who am I waiting for? I'm waiting for Olsen. I'm waiting for Myra, for Nick, for Ryan, for Shalom, for Tati, for Yorshi. I am waiting a lot. A long time for Alexia and Andrea and Brianna and Donovan and Devin and oh come on, and Elijah. I am waiting for Emmanuel and Joseph and both Julianas. So I see Andrea has a negative 4,6. So let's go here. This is very true because I moved to the negative direction here, negative x, and then 6 at the top. So negative 4,6. That's gonna work. And pay attention to the is it positive or is it negative? Well, this was negative cosine Armani, negative x. This is positive for the sine or the y. Remember, the first one is here the x, which is cosine. All right, move on to the third, and all of us again try a point in the third quadrant. Go ahead and try a point in the third quadrant. Give me any point you like in the third quadrant. Any point in the third quadrant. Somebody shine just like Olivia. Come on. You also could shine. Here we go. Ford. Who else? Come on. You could do this. Yep. Don't forget to subscribe and like and share. All right. Let's go and check it out. I see both negatives, which is very true, by the way. If you're here in the third quadrant, both will be negative because it's a negative x, negative y. So let's say just maybe negative 2, comma, negative 4. So both are negatives. You see that? Both are negatives. Negative and negative. Negative and negative. The last quadrant here, can somebody pick a point in the last quadrant? Which is quadrant 4. Pick any point that you like. Any point you like. Okay, I see only 2 of you. I need more. We need to see more of that. Need a point in the fourth quadrant. This is going to help you determine the exact sign. Is it positive or is it negative when it comes down to the actual unit circle. We're going to have to walk around the unit circle here, so don't forget that we're going to do that in a second here. Alrighty. All right. Somebody's giving me. I got Ryan and Myra. Okay. I need to see more of you guys. I'm not sure why it's going on, but you're missing out. If you're not participating, you're missing out. Okay, so that's the point here, and this. Let me just make this. So 5 comma negative 6, meaning every cosine, every x value is going to be negative. Every y value or sine is going to be. I'm sorry. Every cosine is going to be positive. Every sine is going to be negative. So we do have a mnemonics for this in math. If you guys recall, last time we went and said, well, this looks like we could come up with some like a general idea on how do you say stuff here. So it goes like this: all of them are positive. S for student, only sign is positive. All students. T for the third quadrant. Tangent is positive because if you have negative sign, negative cosine, the tangent is going to be positive. All student take, and then the last one is calculus or C. Only the cosine is positive, and that's very true. The cosine is positive here, but not the sine or the tangent. So you could remember all student take calculus. If you forgot, which is perfectly fine, you just pick a point in that quadrant, and that should tell you the actual positive or negative of the corresponding positive or negative of that point. Okay, now we took this kind of tour here on the left because we need to continue with the points on the unit circle counting by 60s or pi over 3s. All right. So here we go. Let's do this one here. This second hop, second stop here. We're going to hop on the 120. Okay, focus with me here. I could still take the 60 here, the 60 triangle, maybe reflected on the other side, but it's going to still be 60. So basically, I'm going to put 60 triangle here as I am thinking about the triangle itself. It's too thick. The triangle itself. So I'm going to put the triangle here, 60. Here is 60. So if you look closely, you're going to find that you also have another 60 here. Just make this a little bit smaller. I have 60 here. And I could use again a thin line for that and dotted line. I put 60 here. What does that mean? Well, this means, Armani, that you have 60 degrees. From here to there, you have 60 degrees. Guess what? That means I could use the same triangle. This guy here, I'm going to use it over here. Just copy and paste it. Better yet, you don't even have to worry about copying and pasting it because you already have the point here. All what you have to do for this dude, for the 120, is you look across. So I'm basically going to take myself and take my eyes and fix them on my friend, which is the 60. I'm going to look across just like that. And if you looked across just like that, you will get the exact same point with minor changes. So I've got 1/2 here, comma, square root of 3 over 2. Okay, what's the minor change in your mind? Well, the minor change refers to the all student take calculus. If you're in the second quadrant, do you think that half would be positive or negative? Somebody tell me. In the second quadrant, is the half positive or is it negative? Is the x positive or negative? It's the second quadrant. The x is what? Positive or negative? Come on. Hello? I'm waiting for more responses. The x is going to be negative. What if I forgot? That's fine. Pick a point. You're in the second quadrant here. Pick any point you like. You will always find the x to be negative. Is this all? Yeah, that's it. So the key is to get 3060 one time only reflected, and that's it. That's all. Then you take this point and then hop over to the other stop. And which quadrant is it in? That's going to determine it's positive or negative. But the same quadrant. But the same point, I should say. Now, what if I wanted to go wild? I would say, okay. You know what? I'm going to hop over here, and I'm going to hop over down here. And you've actually hopped over down here, like this. If you hopped over down here, guess what? It's going to be the same coordinate point. It's going to be the same. This is going to be 1/2, comma, what do you think I'm going to put here? What do you think I'm going to put here? If this is 1/2, and I'm just repeating myself here for the 60s. What do you think is going to be the y here, or the sine? Come on, champions. Hello? Yes, it's going to be that, Tati. Square 3 over 2. That's not surprising. Why? Well, because look, again, from, let's go blue here. From here to here is 60. What do you mean by that, Armani? Well, let me show you. I mean, this is also 60. From here to here, you have an angle of 60 degrees. From this 180 to this line, there's a 60 degrees called reference angle. Reference angle. So this is a 60 degrees. That's why it has the same coordinate, with one exception. What do you think I should have for the x and y here? Are they positive? Are they negative? What do you guys think? I'm in the third quadrant here. I'm in the third quadrant. Is it positive or is it negative, the x's and y's? And again, if you're not sure, pick a point in the third quadrant. You are in the third quadrant here. This is the third. And is it both of them that, or both are? That is very true. Both are negatives. Well, because again, you pick any point. Remember, you pick any point here, you'll end up with a negative cosine and negative sine. Also, look at the actual graph. This point down here is actually on the negative side of the y's. Do you see that? And so on the negative side of the x's. See that? So it's negative x and negative y. That's why both are negative. There's multiple ways you could get to the right solution here. You just gotta pay a little bit close attention. Okay, what's the next hop, do you think? Where's the next hop? What's the next stop? Where do you think I'm headed towards? Fourth quadrant. That's very true. And what's the angle that I'm hitting? What's the angle that I'm after in the fourth quadrant? What's the angle that we're after here? It is 300. If you count by, you're gonna exactly get to 300. So how come 300 is same as 60? Well, again, it's called reference angle. And reference angle means how far are you from the closest x-axis. This is my closest x-axis here. And I got 60 degrees. Meaning I could use 60 as my angle. That's the reference angle, 60 from here to there. So, but guess what? That's going to be a reflection of what you see at the top, or a replica, whatever you want to call it. I'm going to go here and then just reflect it basically here. Basically what we're saying is it's going to be the same quadrant, same point, same points, but in a different quadrant. So what do you think I'm going to put the cosine here? Very true. It will be positive. That's very true. But what's the number that I'm going to put here? What's the actual x that I'm going to put here? I cannot exceed 1, by the way. 1 is my... Look what we've done here. 1/2 square root 3 over 2. 1/2 square root 3 over 2. 1/2 square root 3 over 2. What do you think? It has to be that. That's not magic. And square root 3 over 2. All right. And with some adjustment though, right? Which one is positive? Anyone is positive? Either one is positive? All are positive? Well, it depends. If you're in the fourth quadrant, 1, 2, 3, 4, the fourth quadrant says you have a positive x and a negative y. So basically I have a negative y. That's the only adjustment that I have to make for this guy here. Oh, good Lord. Back to Kiera's question. Kiera quizzed me and she said, was it cosine or sine, Kiera? Did you say cosine 240 or sine 240? Ah, sneaky Kiera. Okay, she said sine. So what do you think is sine 240? What do you think I'm going to put here? Come on, you guys. This question's for all of us. Try to answer Kiera's quiz question. What is sine 240? Sine 240? Anybody? Any takers? Sine 240. It should be here in the point. You just have to look at the point and decide where is that sine. It's in the point. It's all in the point. It's all in the point. I like that, Kathleen. Is it exactly this? Here we go. You did. Yes, you did it. So sine would be, drum roll or not? Look at the point and pick the sine. Let's see the first one to get this one correct. Come on, it's getting closer here. Hurry up, you look at the point and from... I think Brianna meant something. She is looking at which one. Should I wait a little bit? I'm going to wait a few seconds. What is sine 240? Yes, thank you. That's precisely it, Brianna. Negative square 3 over 2. That's this dude here. This is the y, this is the sine. Okay, wow. I do have a few minutes left, so let's do the 45. Okay? Let's do the 45. Any question on this one before we let go? So let's do the 45. Go back to the slices of the pi and tell me what would be pi over 4 equivalent to. What is pi over 4 equal to? Here we go, 45. That's what we're going to talk about right now. So in 45, I have to divide, obviously, my circle into 4 pieces. My pi will be divided into 4 pieces. I'm going to go through here. This is going to go through 1, 2, 2, 3, 4 over here. Every one of these is 45. This is 45. Another 45 will give you 90. Another 45 will give you 135. So let's count by 45s quickly here. So this is 45, yeah, which is at the top here, 45, which is pi over 4, right? Pi over 4. Add another 45, that's going to give me 90. And 90 is how much? Is 2/4 of the pi. 2 over 4, 2 over 4 of the pi, or 1/2, right? 2 over 4 is 1/2 of the pi. So I'm going to go here and put 1/2, or pi over 2. Keep counting with me here. I counted by fourth, 1/4, 2/4, 3/4. How much is 3/4 in terms of degrees? 3/4 of the pi. How much is that in terms of degrees? You're adding by 45s. 45, 45, 45. How much would that be? 3 45s basically is what you're doing. 3 45s. How much would that be? 135. And then you add another fourth, or 4/4, which is a pi, and or 180. And this is a pi. You also add another 180 plus 45. That's 2 to 5. 2 to 5. Somebody confirm that. 180 plus 45 is 2 to 5. Which is how many again? You are counting 5/4 of the pi. And then you're going to add another 45 to that. That's going to give you 270. 270. Which is 6/4 of the pi. 6/4 of the pi. 6/4, you could simplify that to 3 over 2, right? 3 over 2 of the pi. Add another one, 7/4 of the pi would be here. 7/4 of the pi. Which is, how much is this? 315? Because 270 plus 45. 315. And then the last one is going to be the 2 pi's. 2 pi's or 360. So for this one, I actually need to go back to my triangle. And which triangle, Armani? Well, it's the 45-45, my dear. No wonder we spent time on the 45-45. If I have the 45 back to you guys' notebook, this is square root of 2 over 2, and this is square root of 2 over 2. Basically, what I'm saying here, we're giving you the x and y. Square root of 2 over 2 and square root of 2 over 2. Which is going to be exactly the same all across the 45s. What? Yes. This guy's going to be the same. Square root of 2 over 2, square root of 2 over 2. Okay, how about this one here down here? I'm like, same. Square root of 2 over 2, square root of 2 over 2. With one exception. Let's fix this one here. This is in the second quadrant, so the x has to be negative, right? That's the only fix that I have here. This is the third quadrant, so both of them has to be negative. Same point. It just changes its sign. And at 315, I'm also going to end up with, again, what do you think I'm going to put here for 315? What do you think I'm going to put the sine and cosine and sine here? What do you think that's going to be? Well, that's not surprising, right? Yep, it's going to be the same. Square root of 2 over 2, square root of 2 over 2, right? And I just have to adjust that. The sign is negative. That's it. I'm done with the 45. I'm done with the 45. We've done the 60. we've done the 90, and I do have a couple minutes, so let me do the 30. Okay, in the 30, we'll come here and put the triangle. I'm sorry, the unit circle. And then I'll go here and put, and my triangle would be here. And we're doing the 30 here. And remember, the 30 is kind of like this here. And in the 30, you have 1. And then you have, remember, the short guy is a half. And the longer is square 3 over 2. So, and this is 30 here. 30 is here. So basically, I have to cut my circle into, my pi into 3 pieces. I should say 6 pieces. Which means I'm going to go down here. And this guy's going to go here. Which means I'm going to reflect it down here. This boy is going to be down here. Alright, and this guy's going to be down here. These are 30s, okay? So this is 30 here. 30 is pi over 6. So pi over 6 is 30. And guess what? What's the cosine of 30? Well, look at it closely. It's square 3 over 2 and 1/2. And another 30. This is going to be, I could wait for 60 now. Let me do the other 30, which is this side here. That's square 3 over 2 and 1/2, which is 150 here. Another 30 down here. That's the, what's 30 plus 120? 210. You're going to see a square 3 over 2 and a 1/2. And lastly, this 30 down here is going to be the 330 degrees, which again is going to be the same square 3 over 2 and 1/2. I just have to adjust it now. This is a negative cosine, negative cosine, negative sine. This is a negative sine. And that's it. That's how you do the 30 as well. All right, guys. Do not forget to subscribe and shamash the like button. And I'll see you next time. Be blessed.